transformations of trigonometric functions. So our objective here is to find a resultant graph for this transformed function starting from y is equal to sine x. The given domain is on that interval between 0 and 2 pi radians. So before we move on and start graphing this transformed functions, let us go back for a moment and recall the general formula for any transformed function. And let's take a look at the coefficients that are part of the formula. Coefficient A, C, K, and L. You will find different letters for those coefficients, but the meaning, the overall idea will remain the same. So coefficient A, whatever you see in front of the graph, represents vertical stretch or compression. How do we know whether you stretch? So when A is greater than 1, you expect the graph to be stretched vertically. Compression occurs for the values of A that are in between 0 and 1. So what happens when coefficient A is negative? So in addition to vertical stretch or compression, the negative sign causes the entire graph to flip in x-axis. So this is the reflection in x-axis. So the next one here is coefficient C. So this is a horizontal stretch or compression by a factor of C. Stretch occurs for the values that are in between 0 and 1, and compression is defined when that coefficient C is greater than 1. Oops, let me change that. I wanted to say 1, hence it must be 1. Okay. So this is the difference between the vertical stretch and compression, so we read it straightforward. For horizontal, this is the sort of inverted situation. When it's greater than 1, you compress. When the value of C is in between 0 and 1, when you see a fraction, you anticipate a horizontal stretch. Coefficient K, the next constant in the formula, is responsible for horizontal shift, left or right. In the context of trig functions, we will use also the term phase shift instead of just horizontal shift. So when K is, when you see variable x minus a number, what it does, you shift the entire graph to the right. When you see an expression when you have x plus a number, then you anticipate to move the graph to the left. And finally, coefficient L, the constant that is added to the entire y value. So this is simply vertical shift, and L is positive. You go up with the graph, while L is negative, you move the entire graph down. So now before we continue, we have to rearrange the equation. So what that means really, that coefficient inside must be always by itself as presented in this formula. Y is equal to A times F in bracket C. So see, please note that this is by itself. So we have to factor out 2 from this binomial. So take out 2, bring it outside. So what goes inside? Variable x. And then you have to divide pi over 3 by 2. So you'll get pi over 6. So this is why, if you choose to ever go back to the original statement, you must have 2 times x, which is 2x, minus 2 times pi over 6, which will give you pi over 3. So this way you can always make sure that it is done properly. Also, because we call a graph for sine x. So this is little x and y axis here. So the original graph, sine x, will look somewhat like that. So where the wave is completed on that interval 0 to 2 pi, so in this case the period of that function is 2 pi. The altitude is the difference between maximum value and the minimum value divided by 2. So if the spread here is between 1 and -1, so the difference is 1, take away -1, it's 2 divided by 2 is 2. So this is the y, the amplitude is 1 unit. The amplitude is 1, the period is 2 pi. In general, the period is found by the following formula, 2 pi divided by that coefficient c. So since the c from our equation is 2, so you expect now to have the period equal to pi radians, because 2 pi divided by 2 will give you just pi radians. So the new graph will occur twice on that interval 0 to 2 pi. You have one wave between 0 and pi, and then another wave between 0 and 2 pi. So the graph here, represented by the blue wave, is sine x for now. And now we will proceed to find images of certain points from the graph. So 0, 0, this is pi over 2, and 1, pi and 0, 3 over 2, pi, and -1, this is 3 over 2, and 2 pi, comma, 0. So the mapping formula. So we have the coordinates of x and y. Any coordinates on that function y is equal to sine x, and then those coordinates are being mapped into x prime, the image of x, and y prime, the image of y, using this new transformed function. So what happens, let us find the coordinates of image x prime when you replace in the formula, you replace x with this entire statement here. So this is why we say the image x prime now is equal to 2 times x minus pi over 6. So from this equation, let us find what is x, because we will have to go back and see what formula will be used for. So in the process, you will see that you have to expand it by 2. So that's the next step. Continuing simplifying the equation, and now moving into the step where x has to be isolated. So this is why you move pi over 3 over to that side, and then eventually divide both sides by 2 to single out x. So the image, in terms of the value of x, would have this formula. So this is why x is mapped unto this value. In terms of coordinate y, this is much easier, because what you see that the function y is equal sine x is multiplied by -2. So this is why you have -2 times y, and then you add 1 in the end. So this is why the image for y has this formula here, -2y plus 1. So this is very straightforward when you're talking about the y coordinates. For the x coordinate, you will have to solve that equation to see that the effect of the transformation. So coefficient 1 over 2, because we talked about compression, and then you add pi over 6 because you moved the graph to the right. So this makes sense now when you look for the transformation of that function. So now we have the key points of the original graph 0, 0, the transformation into pi over 6 and 1. How so? You simply use this mapping formula, and then you would say if x is 0, y is 0, what is the new coordinates when x is 0, and what is the new coordinate of y when y is 0. So by substitution, you see that half times 0 plus pi over 6 gives you that, and this is straightforward. Negative 2 times 0 plus 1 gives you 1. So over here, back to that. So this is why this point 0, 0 is transformed into this pi over 6, comma 1. The next one, pi over 2 and 1. So the image is 5 over 12, pi and negative 1. And this is obtained by using, again, the same mapping formula. You replace x with pi over 2 and y with 1. So in the process you add and you work with fractions. So when you work with fractions, you have to understand that I need to add only, I can add only when the bottom, the denominator is the same. So this is why you have to change this to 12 times 3, this to 12 times 2. So in the end, you will see that you have pi over 5, pi over 12, and negative 1. And then you can do the transformation for this point, for the next one, and the last one, 2 pi. So 2 pi replaced here will give me 2 pi divided by 2 is 1 pi plus pi over 6. So this is 7 over 6 pi. How do you know that? Because 1 pi is 6 over 6 plus 1 over 6 gives you that. And the y value, so when y is 0, you get 1. So those are the images for those selected points. So any other point on this graph will be mapped by using the same formula. So you can find essentially any image for any selected point on that original graph. Putting everything together. So the first wave from the previous page, you could recognize y is equal to sine x. The one in solid blue. So this is the graph right here. So the first step we could do is to do this stretch by factor of 2, the vertical stretch, and then compression by factor of 2 again. So you would see this dotted blue curve. So instead of going from 0 up to 1, now you go from 0 all the way up to 2, because this is the amplitude now. And then over the period of pi radians, you expect it to complete 1 full cycle, because now the period is pi radians. The amplitude is 2 units. So you have one wave from 0 to pi, the second wave from pi to 2 pi. So this is the step 1, the original. So this would be our step 2. Then negative coefficient, if you recall, causes the entire graph to be reflected in x-axis. So that blue dotted curve now is going to be flipped, the mirror image in the x-axis. Well, this is the x-axis. This is the y-axis here. So the step number 3 is just the reflection. So the one in red. So the next step, since we have the graph reflected, will be the horizontal shift pi over 6 units to the right. So this is step number 4. And then we have this entire graph, the red dotted graph, shifted just 1 unit, not 1 unit, pi over 6 radians, and see, this minimum value will be shifted here, and so on. So that is this step, represented in black dotted line, a dotted curve. So finally, step 5, the only part that is needed is the shift, vertical shift 1 unit up. So this is why we move this 1 unit up, the entire graph 1 unit up from the minimum value, 1 unit up, 1 unit up. So every point on the graph is transformed by 1 unit up. So the minimum value from -2 goes up to -1, and the maximum from 2 goes up to 3. So the spread along the y-axis remains to be 3 and 1/4 units. So when you do the amplitude, so you divide minimum, the difference between maximum and minimum is 4 divided by 2 gives you 2. So that makes sense. And the period now is pi, because that was established already before. And now you could think of, so what happened to the image of my point 0, 0? Remember from the previous page, 0, 0 was transformed into pi over 6 and 1. So somewhere here, this is not to scale, pi over 6 and 1. So that will be the image of that point. Oops, I said 1, and I have to show 1. Pi over 6 and 1. And you can use all those points, pi over 2 and 1, to show where is the new image and so forth. So the entire graph, to summarize, was stretched and reflected by, was stretched vertically by a factor of 2 and reflected in x-axis. The period was changed, was compressed from 2 pi radians to pi radians, so by a factor of 2. The graph was also shifted pi over 6 radians to the right, and then the entire wave was moved up by 1 unit. So I hope that that was clear explanation of transformation of trigonometric functions, and I hope you enjoyed this video, and I'll see you next time.